On behalf of the Manufacturing Outreach Center, I'd like to welcome everyone to the October Manufacturing Advantage webinar. Today we'll be hearing from Collin Suebert from Rhino Tool House as he shares different types of warehouse automation technology and how it can be applicable in an operation. Participant mics will be muted for the presentation, but there's going to be an opportunity to ask questions. Please feel free to type any questions you have in the chat as well. And with that, we'll hand it over to Collin.
So, like I mentioned, I work for a company called Rhino Tool House. If you aren't familiar with us, we are a half supplier, half manufacturer. So we represent a number of brands, thousands of brands, in the material handling space, assembly tool space, part presentation space. I'll get to that a little bit. And then we also have a manufacturing wing. So in Franklin, Indiana, just outside of Detroit, Michigan, and just outside of Charlotte, North Carolina, we have manufacturing hubs where we make our own conveyors, automated conveyor systems, and part presentation racks, much like what you see behind the gentleman on the right side of the screen, that tube and joint style configuration. We own a company called CTech Manufacturing that makes that in the Carolinas. We cover all of the 48 lower states, and we just opened a branch in Mexico. And the idea behind that is a lot of our customers have locations scattered across the country and North America. And we want to give them the same service that we do here in Wisconsin as we would in, say, Charlotte or Texas or Monterrey, Mexico. And we can do that with our footprint. So a little bit about what we do at Rhino Tool House before we hop into today's topic. We take a consultative approach to manufacturing problems. So most of our customers, they aren't calling us to say, hey, I want to order this part number. We're not a Grainger or a Fastenal. Most of the time, our customers call us in to solve problems. And it's my job and Hunter's job to take a bit of a consultative approach and really dive into the problem that we're looking to solve. Again, we represent thousands of brands, so we're not trying to, shove a circular tube into a square hole, right? So some examples of what we do here, starting left to right. We do a lot with cobots, right? So that little yellow guy there is a cobot. We do a lot with lift tables, jibs, articulating or standard jibs, overhead cranes from your standard small half-ton workstation crane up to 20-ton, 100-ton systems. That wasn't supposed to happen. Okay. I mentioned conveyors earlier. Obviously, we tackle conveyors, floor mats, part presentation equipment, and then your standard RMO stuff like sockets, bins, and items of such. But most of our customers, we usually work with them on a bunch of what we call our manufacturing pillars, from material handling, fastening, and what we're going to cover today, our AMS, which is our advanced manufacturing solutions, where things like cobots and mobile robots fall into. So hopping into the topic of the day, which is autonomously moving materials through the facility. So a couple acronyms up here, if anyone wants to hop in. What does AGV stand for?
Automated Guided Vehicle.
Boom, boom. Yep, and in this space, that is the oldest technology, and I'll explain, it still has a place today. How about AMR?
Autonomous Mobile Robot.
Boom, autonomous mobile robot. Good. I mentioned autonomous pallet robots are newer to the space. Basically, it's an AMR, uses the same type of technology, and again, I'll dive into this a little bit further, but it's focused on pallets. So what AMR companies found was that a lot of what they were moving were on pallets, so why don't we dedicate robots specific to pallet movement and getting them from the ground to the destination. That was the challenge, right? Most AMRs needed to tunnel under something, whether a cart or some sort of conveyor system, much like what you see on the right here. The APR was specific for pallets and taking pallets from the ground, moving them to a different spot in the facility, and again, resting them on the ground, so we don't need any docking stations. So the first technology I want to cover is the AGV, the Autonomous Guided Vehicle. And like I mentioned, this is the oldest technology. The company I'm highlighting here, Daifuku, also known as Jervis Webb in other parts of the country, they are the oldest manufacturer of this type of technology. They have the most vehicles installed across the world, and they service a number of large customers, some here in Wisconsin. Mercury Marine has a bunch of these AGVs, and so does John Deere in Horicon. And the AGV works much like a train. It has some sort of track to follow, whether that be a tag line, an RFID line, a mag line, something in the floor that is incorporated into the foundation that the AGV can follow, right? And the AGV, in my opinion, is best suited for situations where cycle time matters. If my vehicle is not in this position at this specific time, it could potentially cause downtime or an interruption in the production line. And for companies like Mercury Marine and John Deere, that's very critical because every second counts, and they work a lot like an automotive company in pounding out, whatever they're making. So the AGV still has its place because it's going to be in that point at any given time that you specify it be at. It's going to move at the same speed. The challenge with the AGV is you need to make some sort of infrastructure change, and you also need to make sure that you're staying clear of that train track, I'll call it, right? You can't set stuff down in that area because the vehicle will simply stop. It's not going to go around and maneuver through the facility around objects. That train track needs to be cleared off at all times. Daifuku can do a number of different styles of robots, and we're going to watch a little video with more on Daifuku. There is no sound with this video, so don't worry about it. But you'll notice the tagline covered with tape on all of these. So again, AGVs must follow some sort of tape line. One other benefit of an AGV is payload. They can carry a lot more weight in most situations than that of an AMR or an APR. The next product I want to highlight is an AMR from Mobile Industrial Robots. They were the first to the AMR space. They're a company out of Denmark, and you'll notice that a lot of AMR brands do come from Denmark. I'm not sure why that is, but Mir was the first to the space, and they have the most implementations of anyone here stateside. And here's a short overview of Mir.
We are constantly looking for ways to optimize our productivity and efficiency. The use of mobile robots enables us to implement these optimizations in order to improve our efficiency, productivity, and safety.
They autonomously transport material and empty containers between warehouse and assembly. For this task, they're equipped with the MIR hook.
We use MIR as a conveyor belt. We use it to transport our semi-finished products and our finished goods, but from production cell to production cell.
3 MIR transport robots are now the adaptable link between different production lines. This is a new way to produce that enables Camstrup to upscale without any production downtime.
We are currently using 7 of them with 3 different top modules. They are capable of detecting obstacles, and we not only track their location, but also their task at all times.
We started on the MIRs just doing manual assembly line stuff in a very basic format. We upgraded the MIRs to have a conveyor system on them. They can now go down to the warehouse and collect raw material, and then they can deliver that to the lines. By putting the conveyor on the MIR, we gain the flexibility of being able to move anything where we want around the factory.
Fortunately, with MIR, they have an open interface, so we can connect third-party equipment to the robots.
Good number, but
We chose MIR as our mobile robot because it was a flexible solution in which we could see a lot of potential.
We were looking for a solution that could have the payload up to 500 kilograms, and MIR was up there for the task. And we were also looking for a solution that would be easy to set up and fast to start operating. And we also were looking for, of course, a safe system that could work with the truck drivers. This has increased our productivity.
We have already proven that these robots are able to learn their route by themselves, as well as that they are perfectly able to interact with our employees and forklift trucks in complete safety.
Making the robot easy to use was extremely important to us. I would split the ease of use into 2 parts. First, how easy it is to use the robot itself, and second, how easy it is to use our application.
All right, so you'll notice in the video there wasn't any tape on the floor, right? The AMR is exactly what it sounds. It's an autonomous mobile robot. So it uses LiDAR, vision sensing, and safety scanners to navigate the facility. So the robot will map out the facility. You'll drive it around, or someone like myself will come in, one of our application engineers, and map out the facility, mark fixed, their static versus dynamic objects within your facility, and then a combination of the LiDAR and vision with encoders in the wheels tell the robot where it is at any given time, right? And the beauty of the AMR is it can navigate around people, around objects, and it's not going to follow that linear train track pattern every time. Now, the downfall to that is they're not great when cycle time or tack time are critical, because the first time it goes from point A to point B, it could go a complete different direction the next time based on what it encountered the first time. And maybe it takes 1 minute and 30 seconds this time, and next time it takes 1 minute and 47 seconds. It's variable depending on the environment and what the robot's general AI thinks is the best given direction from point A to point B at any given time. So you'll see a little bit here of the fleet. They have their MIR 1200, which will do up to 1200 kilograms, all the way down to their MIR 250, which is capable of 250 kilograms, or that 500 pounds. And then they also have a hook, which is popular, and really MIR is the only one in the AMR space that has anything like it, but it is what it sounds like. It will actually grab onto any cart as opposed to lifting it off the ground or pin attaching. So I like to make the analogy of an AMR is like a robot arm, right? So you have your arm or you have your AMR, And then there's some form of top module that's much like, a gripper on a robot, right? So your top module is what makes the robot usable. There's a number of top module options in the AMR space. One of the largest manufacturer of top modules you actually saw in this video, and they'll work with any brand, whether it be Mir, whether it be Robotize, whether it be Omron, or anyone else in the AMR space. You strap the top module onto the robot, and it can now pick carts up, set carts down. You can put a conveyor top module on it to literally marry it up to any automated conveyor you may have in your facility. All of this is possible, and most AMR companies have an open protocol software that will communicate with just about any language to any sort of PLC or data-driven ERP that you may need. On the left here is the Mir pallet jack, which is now released, and we're actually going to get the first demo of this pallet jack here stateside in December. So we're actually bringing it up to GreenHeck, the GreenHeck group up in the Schofield area or the Wausau area in December. So that's exciting. Obviously, you can use it to move pallets from the ground, but you can also use it for a variety of other things. And in GreenHeck's case, we're going to use it to move carts where we couldn't fit one of their standard vehicles underneath the cart and successfully move it. So that's a little bit about Mir. The next one I want to talk about is Robotize. Robotize is a lot like Mir from a navigation standpoint, from a payload standpoint. They were probably a year or two behind Mir, and like Mir, they're also manufactured in Denmark. It's my understanding that Robotize was created by a few of the original founders of Mir. Robotize shook up the market in that their price point is a little bit less than Mir. You'll find this in a lot of industrial sectors, right? The first one to market, the one with the most bandwidth behind them, most installations, they tend to have the highest price, where some of those coming to the market after the fact, right, try to shake that up a bit. So the Robotize on average is 10 to 15% less than the Mir, but operates very similarly. Same mapping capabilities, same multiple robot interface, and one unique aspect of the Robotize that other AMRs don't have is their bumper system. So yes, there are safety scanners on all of these robots and all AMRs, but there are some floor objects that the safety scanner can't pick up because it sends a linear plane out into the world, right? So if there's something very, very small on the floor, it will detect, say, a foot, but it's not going to detect a forklift fork because it's too flat, right? And it could come in contact with that. So the bumper system, what it does is if it comes in contact with anything, it will stop the robot and make sure that everything around it is stopped as well. So that's a little bit about Robotize. I don't have a video on them. The next company I want to highlight is pretty cool in this space. It's a company called WheelMe, and they essentially take or remove casters from any standard cart and put their WheelMe on it and turn any sort of cart into an AMR. WheelMe is unique in that no top module is required. It's a very simple navigation system, and their price point to actually physically create an AMR is the lowest. I would estimate that WheelMe is in the 20 to 25 grand range, where a similar capacity robot from Robotize might be 60, and a similar capacity robot from Mir might be 70, right? Just to give you a little feel and flavor for pricing some of this stuff out. But I have a short video that I want to share on WheelMe. I just want you to know that it's an AMR, uses the same, LiDAR and vision that, say, the Mir or the Robotize does. It's just you simply remove casters from a current cart to the WheelMe. So here we go. one more here. There is no sound for this one. That's a little bit on WheelMe. I guess the important other thing to note is so it works like any other AMR. It's just you're dedicating a specific cart to the job. So for example, with RoboTies or Mir and a top module, you can move 10 carts and all of them may be dedicated to something else, right? With WheelMe, it's now that singular cart is dedicated to that process. So it's not as flexible as maybe a Mir or a RoboTies with a top module. The next company I want to highlight is Tusk Robots, and they were the first to create a dedicated APR, so autonomous pallet robot. And the challenge that they saw in the market with the AMR industry was, hey, we're moving a lot of pallets, but no one's solved the problem of taking a pallet from the ground and moving it autonomously. So Tusk was the first to do that. They released a number of different types of robot. One that works more like an AGV and works with QR codes on the ground, and one that uses LiDAR and vision, much like your standard AMR, and then one that uses a hybrid system. So AMRs typically look to have about 60% static objects within their route. If the facility is too dynamic and there aren't static objects, the robot could potentially get lost. So Tusk is generally used in warehouses where maybe there's pallets and pallets all over on the ground that are always moving. And that's why they decided to use a system that maybe is hybrid or focused at, the AGV or the AMR, just because some areas they require that static rigidity and navigation. So I'm going to share another video that will further explain Tusk. One more. That was just a look into the shuffle slide system, which is pretty unique. That's how they solve the problem of getting pallets from the ground onto the robot. So here's another video. Sorry, I had someone hop in here. I'm actually at one of our customers. We're doing an install. I'm at the new ABB factory in New Berlin today, and someone came into the conference room I'm in, and so I apologize for that. But yeah, that's a bit on Tusk, right? They solved the problem of taking a pallet from the ground and successfully transporting it and placing it on the ground in a different location. So some of the overall, aspects of what we've seen today. I want to point out that my company, Rhino Tool House, we implement AGVs, AMRs, APRs, and again, we kind of take a consultative approach for what's best for each application. And everyone's needs are different. And it's my job, it's Hunter's job, it's everyone that we have scattered across North America's job to evaluate that with our customers and determine the best solution for the specific application. Everything you saw today, we do have demo equipment, whether that's a Mir, a Robotize, a WheelMe, a Tusk, a Daifuku AGV. We can bring it to your facility. We can host you at one of our satellite facilities and show you the technology live and in action. But I think it's important to note that all of these forms of technology are collaborative in nature, so much like a collaborative robot, right? It's not going to come in contact to people. It's going to work and navigate around tuggers, around forklifts, and around anything within its path. If it's an AGV, it's simply going to stop. If it's an AMR, it's going to walk around. All of them have what I like to call their air traffic controller, right? Much like an air traffic controller at an airport. All of these systems have a software that work at a high level to manage the fleet of robots or AGVs, to call out commands, tell it where to go, communicate directly with the ERP to say where picks and drop-off locations are, and all of that such. We help with a lot of that integration, mapping, and what most of these companies call missions, right? Your point A to point B, or maybe point A, point B, point C, right? Every operation is unique. Just a little bit on some of the cost of this stuff. I touched on the WheelMe, the Mir, the Robotize. Tusk is going to be closer to that 60 to 100K depending on payload, and anything Daifuku or AGV related generally going to cost a little bit more just because of the infrastructure needs of putting the tape or QR guidance on the floor, the mag strip into the floor, whatever it might be. They technically will cost a little bit more. Yeah, the vehicle might be less, but the overall installation cost is certainly going to be more than an AMR. So that basically sums everything up within this space. And I appreciate everyone's time. And at this point, if there are any questions, would love to field some questions.
I'm curious about why Northern Europe is exploring this and developing it.
Yeah, that is an interesting, yeah, why this technology comes from Denmark. I
Yeah,
don't I don't know the response to that. I mean, historically, automation is not a strong suit of United States manufacturing. I mean, a lot of your robot brands are European, German, or Japanese. And uh, I think this sort of follows suit with the European ideal, I guess. Tusk is technically a Chinese brand. Um, but yeah, there isn't an AMR made here in the United States, and it is interesting that a lot of them come from Northern Europe. But to your point about non-value added time, right? It's everyone's
yeah.
struggling to find good workers or to retain employees, and I don't think there's a single person that wants to push around carts all day. And
No, I think
we,
this is great, actually. I mean, it's great to see. And
yeah,
yeah, I just gotta include that in value stream mapping. It's like, oh, got an option here. So
mhm,
yeah.
yeah.
Um, so and other question I had was cost. Is that one
Mhm.
time or leasing, or how does that work? You buy it
Yep.
and then
Yep. So you buy it and you own the vehicle. Um, we have done a few leasing programs. It's not as common, but typically you buy the vehicle outright, you own the vehicle, and then there's a cost to us coming in and helping with programming
right,
and integration if that is something you guys are interested in, or whoever the customer might be. Some of these companies do offer different sort of service plans that are more uh, SaaS based, so annual. For example, Mir, one of their service contracts can cost you $1,000 a year to get their basic service. So that's
hmm
if you have a problem, within 24 hours, someone will support you, whether that be on site or through video chat. But that's really where us as the distributor come in, right? You'd call me, you'd call Hunter, and one of us would come and help with whatever it might be. You need to replace your casters. One of your safety scanners got hit by a forklift and needs to be replaced. That's where we come in as the distributor and the representative of the product,
sure.
um, and where we shine. So,
No, that's good. Thank you.
mhm. Awesome. Well, if anyone has any questions, I shared my contact info in the chat, and feel free to give me a call, send me an email, whatever's best for you, and I'd be happy to help. So, thank you for the time, and we'll give everyone back 17 minutes. Enjoy the
Sure.
rest of your
Thank
day.
you.